Honestly, when you pause for a moment, away from the noise and the endless scroll, and you truly consider it, what is the most profound question you can ask? Not about your job, not about your relationships, not even about the meaning of your own life, but about everything. The whole show. The entire cosmic stage upon which our fleeting little dramas play out. Why is there all of this instead of nothing at all? Why does the universe exist? For most of human history, and indeed in most places on our little planet today, the answer to that question isn't sought, it's received. It's handed down, a prepackaged certainty wrapped in ancient texts and solemn ceremony. A creator, a purpose, a grand design. It's a comforting thought. A story with a beginning, a middle, and an end, all orchestrated by a familiar protagonist. But we here at the God Mirage are interested in questions themselves, not just the comfortable, hand-me-down answers. We prefer the thrill of the intellectual chase over the comfort of a predetermined finish line. So, to start our journey today, I'm genuinely curious. In your corner of the world, what's the default, unquestioned answer to that ultimate question? What's the go-to explanation that most people would give without a second thought? Drop a comment below and let us know. It's a fascinating way to map the world's inherited ideas. And while you're down there, a simple click on the like button and a quiet tap on subscribe are the best ways to signal that you, too, are ready to look beyond the mirage. Today, we're not just going to question the answers, we're going to question the question itself. The why trap. Before we can even begin to sketch the faintest outline of an answer, we have to perform a bit of intellectual hygiene. We must first deconstruct the very tool we're trying to use, the word why. This simple three-letter word is perhaps the most loaded, most human, and most misleading question we can ask of the cosmos. Our minds, these magnificent, pattern-seeking lumps of electrified fat, did not evolve in a sterile philosophical laboratory. They evolved on the savannah, in the forest, in small, chattering tribes where survival depended on correctly guessing intent. Why did the leaves rustle? A predator might be hiding? Why did our neighbor share his mammoth steak? He likely wants a favor in return. Why did the shaman say we must sacrifice a goat? He intends to reinforce his authority or appease a perceived threat. Every why question in our ancestral environment pointed back to a mind, an agent, a purpose. Our brains are, to put it bluntly, exquisite agency detection machines. We are so good at it, in fact, that we see it everywhere, even where it doesn't exist. We see faces in clouds, malice in a thunderstorm, and benevolence in a good harvest. This is the bedrock of superstition, of mythology, of all the pantheons man has ever dreamed up. It is an evolutionary feature that has become a philosophical bug. So, when we stand back and cast our gaze upon the entire universe, the silent, sprawling, indifferent cosmos, and ask, why? We are instinctively, subconsciously loading the question. We are smuggling an assumption into the very premise of our inquiry. The question, why does the universe exist? Isn't a neutral scientific query like, what is the mass of an electron? It subtly implies a purpose, a reason, a motive. It's fishing for an agent. It frames the universe as an act, a creation, something done by a consciousness for a reason. And when you frame the question that way, you have already predetermined the category of possible answers. The answer must, by the question's own logic, involve a mind. Think of it this way. If you find a watch on the beach, it is perfectly reasonable to ask, why is this watch here? The answer will involve a watchmaker who designed it and a person who dropped it. Agency and purpose are entirely relevant. But if you point to a particularly interesting-looking rock on that same beach and ask, why is this rock here? The nature of the question changes. A geologist will tell you how it got there, the eons of sedimentary pressure, the tectonic uplift, the slow, grinding erosion by wind and water that gave it its shape. They will answer the how. If you persist in asking why, as in, for what purpose was this rock placed here? You are now no longer in the realm of geology. You have leaped into the realm of mythology, assuming a celestial rock placer with an artistic flair. This is the why trap. By asking it of the universe, we are projecting our own psychological architecture onto the fundamental nature of reality. We are assuming the cosmos operates on the same principles as a human social group. It's a profound category error, like asking for the color of jealousy or the weight of a Tuesday. It's possible the universe doesn't have a why in the way we mean it. It may only have a how. And accepting that possibility is the first crucial step toward genuine understanding. It requires us to gently set aside our intuitive, evolved craving for narrative and purpose, and instead to embrace the far more challenging, but ultimately more rewarding, pursuit of mechanism and principle. To ask not for the universe's motive, but for its recipe. The brute fact and the necessary being. Once we've acknowledged the why trap, we are faced with two starkly different paths forward. The first is perhaps the most intellectually austere and, for many, the most disquieting. It is the concept of the universe as a brute fact. A brute fact is something that is not explained by anything else. It simply is. It's the final stop on the explanatory train, the ultimate axiom. In this view, the existence of the universe is the foundational reality upon which all subsequent explanations are built. You can ask why the Earth orbits the Sun, and the answer is gravity. You can ask why gravity works the way it does, and the answer lies in the curvature of space-time as described by general relativity. You can continue this chain, going deeper into particle physics and quantum fields, but eventually you will hit a wall. You will arrive at the most fundamental laws and components of reality as we can describe them. And at that point, if you ask, why this set of laws and not another? The brute fact response is simply, that's just the way it is. There is no deeper reason. The universe exists with these properties in the same way that a primary number is a primary number. There is no why for its existence, any more than there is a why for the existence of logic. It is the very canvas upon which any and all whys could even be painted. This idea is profoundly unsatisfying to our story-hungry minds, but it is a logically coherent and powerfully simple position. It doesn't invent new entities. It doesn't appeal to the supernatural. It simply states that the explanatory chain has to terminate somewhere, and the most logical place for it to terminate is with the thing we are trying to explain: existence itself. The universe isn't the answer to a question. It's the very medium in which questions are possible. But of course, this is where the theologians and the philosophers of a certain persuasion cry foul. They find the idea of a brute fact universe intellectually lazy, an abdication of the quest. For them, a contingent thing, something that could have been otherwise like our universe, cannot be the ultimate explanation. It requires something more fundamental to explain it. This leads us down the second path to one of the most famous and persistent arguments for the existence of a god, the argument from unnecessary being. Popularized by thinkers from Aristotle to Thomas Aquinas to modern apologists, the argument in its various forms goes something like this. Everything we observe in the universe is contingent. It depends on something else for its existence. You are contingent on your parents who were contingent on theirs, and so on. The Earth is contingent on the formation of the solar system. This chain of contingency cannot, they argue, go back forever. An infinite regress of causes is considered logically problematic. Therefore, the chain must terminate in something that is not contingent, something that exists by its own nature that could not fail to exist. This entity they call the necessary being. And then, in a move of spectacular, unearned confidence, they slap a label on it: God. This argument feels powerful. It has an internal logic that seems, at first glance, quite compelling. It neatly solves the brute fact problem by positing a foundational reality that is self-sufficient. But as we start to examine it more closely, the entire edifice begins to wobble. The first most obvious problem is the glaring fallacy of special pleading. The argument's entire premise is that everything requires an explanation, that contingency must be resolved. But then it posits one single entity, the necessary being, that is magically exempt from this very rule. When the skeptic asks the perfectly reasonable follow-up question, and what created the necessary being? Why does it exist? The answer is a verbal shrug. It's necessary. It doesn't need a cause. This is a textbook case of defining your conclusion into existence. You set up a rule for the entire universe and then create a single, custom-made exception that just so happens to be the very thing you wanted to prove in the first place. It's an intellectual get-out-of-jail-free card. Furthermore, the very premise that everything that begins to exist has a cause is not the ironclad law it seems to be in our everyday macroscopic world. When we dive into the bizarre and counterintuitive realm of quantum mechanics, the very concepts of cause and effect become fuzzy and probabilistic. Virtual particles, for instance, are pairs of matter and antimatter that pop into and out of existence from the vacuum of empty space, seemingly without a direct deterministic cause. Their appearance is a spontaneous fluctuation of quantum fields. Now, apologists will argue this isn't truly creation from nothing, as it happens within the existing framework of physical laws and quantum fields. And they are right, but that's the point. It fatally undermines the intuitive, classical notion of causality that the necessary being argument so heavily relies upon. If the universe itself arose from a quantum state, a possibility we'll explore next, then our simplistic billiard ball logic of cause must precede effect may not apply at all. The very first premise of the ancient argument is built on the shifting sands of a classical intuition that simply breaks down at the fundamental level of reality. So, the necessary being, far from being a logical necessity, begins to look more like a failure of the imagination. It's an attempt to force the baffling, non-intuitive nature of ultimate reality into a familiar human-sized box labeled purpose and mind. From nothing to something. So, if we set aside the why trap and we find the necessary being to be a case of special pleading, we're left with the most mind-bending question of all. How could a universe, all of this, the galaxies, the stars, you, me, arise without a reason and without a creator? How can you get something from nothing? This question has been the trump card for theists for centuries. It seems like the ultimate absurdity, a violation of the most basic law of existence. And yet, modern physics, in its deepest and most speculative explorations, has begun to whisper a possibility that is far stranger and more elegant than any ancient creation myth. The first step in untangling this puzzle is to be very, very precise about what we mean by nothing. When a philosopher or a theologian speaks of nothing, they typically mean absolute non-existence. No space, no time, no matter, no energy, no physical laws, no potential, a true conceptual void. The problem is, this state of absolute nothingness may not even be a coherent concept, let alone a physical possibility. But when a physicist talks about nothing, they mean something quite different. They mean a quantum vacuum. And a quantum vacuum is not empty, not in the slightest. It is a roiling, bubbling, seething cauldron of potential. It is the ground state, the lowest possible energy level of the universe. But this lowest level is not a placid zero. Due to Heisenberg's uncertainty principle, which dictates a fundamental trade-off between knowing certain pairs of properties like energy and time, this vacuum is alive with activity. Fields, the fundamental stuff of reality, are constantly fluctuating. And out of these fluctuations, as we mentioned earlier, virtual particles can spontaneously borrow a tiny amount of energy from the vacuum to flash into existence as a particle-antiparticle pair, before annihilating each other in a flash of light and paying back the energy debt. This happens everywhere, all the time, in the emptiest regions of space. The vacuum, the physicist's nothing, is therefore a place of immense latent potential. It is not the absolute void of philosophy. It is a nothing that possesses the inherent potential for something. It contains the seeds of existence woven into the very mathematical fabric of physical law. This leads to an even more profound idea, a concept floated by physicists like Alan Guth and Lawrence Krauss, the zero-energy universe. This hypothesis suggests that the total energy of the entire universe might be precisely and exactly zero. This sounds insane. How can a universe bursting with the phenomenal energy of a quadrillion stars have a total energy of zero? The answer lies in a cosmic balancing act. Matter and radiation, like the stars and galaxies, represent a massive amount of positive energy, thanks to Einstein's EOMC2. But there is another player in the game: gravity. Gravity, in the language of physics, is a source of negative energy. Think about it. To pull two objects apart against their gravitational attraction, you have to add energy to the system. This means that the gravitational field itself stores negative energy. The calculation is complex and not yet definitively proven, but it is entirely plausible that for the entire universe, the colossal positive energy of all the matter is perfectly and exactly cancelled out by the colossal negative energy of all the gravity holding it together. If this is true, the implications are staggering. It means that the universe in its totality has the net energy content of nothing. It could have arisen from a quantum vacuum fluctuation, a random flicker in the nothingness, without violating any laws of energy conservation. Because if the total energy is zero, you don't need any energy to create it. The universe could simply be a fancy, elaborate, and rather beautiful way of rearranging nothing. It's like digging a hole on perfectly flat ground. You create a pile of dirt, the positive energy of matter, but you also create a hole of equal volume, the negative energy of gravity. The net amount of dirt and hole you've added to the landscape is zero. You got something from nothing, but the books are perfectly balanced. The universe could be the ultimate free lunch. Let's just pause here for a moment, because this is not an easy idea to digest. This concept, that the entirety of existence, with all its splendor and complexity, could be a grand cosmic balancing act of zero, can be either deeply unsettling or incredibly elegant. It removes the need for a prime mover or a grand injection of divine energy at the beginning of time. What is your gut reaction to this? Does the zero-energy universe feel like an accounting trick, a clever cheat to get around a difficult problem? Or does it resonate with you as a beautiful, simple, and self-contained solution? Share your immediate, unfiltered thoughts in the comments. I'm fascinated to see how this radical idea lands with different minds. Because whether you find it beautiful or bizarre, it represents one of the most exciting frontiers in our quest to understand where all of this came from. It suggests that the universe didn't need to be willed into existence by an external power. It could have been an entirely natural, spontaneous event, an inevitable consequence of the laws of physics playing out on a canvas of quantum nothingness. The cosmic seed. So, if the universe can indeed be a zero-energy free lunch, a grand balancing act between positive matter and negative gravity, how did the meal get served? How do we get from the featureless, potential-filled nothing of the quantum vacuum to the lumpy, structured, galaxy-spangled cosmos we inhabit? The journey from that initial state to this one is perhaps the most violent, dramatic, and mind-boggling story in all of science. It begins not with a bang in the traditional sense, but with the planting of a single, impossibly dense cosmic seed. When we speak of the Big Bang, our minds conjure an image of a bomb going off in the center of an empty room. This is completely wrong. There was no room. There was no outside. The Big Bang was not an explosion in space, it was the explosion of space itself. Every point in our observable universe today was in that first moment, occupying the same place. An infinitesimally small, unthinkably hot and dense state known as a singularity. At least that's the classical picture. In reality, general relativity, our theory of gravity, breaks down at these scales. Quantum mechanics must take over. So it's more accurate to think of the initial state not as a perfect point, but as a chaotic, probabilistic fuzz of quantum foam, a roiling sea of potential universes where the laws of physics as we know them had not yet crystallized. From this quantum foam, one tiny patch, unimaginably smaller than a single proton, underwent a transition. A quantum fluctuation tipped it into a very peculiar state. This is where the theory of cosmic inflation enters the stage, and it is the single most important idea we have for understanding how we got from then to now. Proposed by physicist Alan Guth in the 1980s, inflation posits that for a tiny fraction of a second, from about 10 to the minus 36 seconds to 10 to the minus 32 seconds after the beginning, the universe was dominated by a powerful, repulsive gravity. This anti-gravity field caused the fabric of space-time itself to expand at a truly astonishing exponential rate. To say it expanded fast is a laughable understatement. During this brief flicker of time, the universe at least doubled in size 100 times over. A region smaller than an atom inflated to become larger than a galaxy, far, far faster than the speed of light. Now you might be thinking, hold on, nothing can travel faster than light. And you are correct. But that cosmic speed limit applies to things traveling through space. Inflation was the expansion of space itself. It's like two dots on the surface of a balloon. You can't move the dots across the rubber faster than a certain speed, but you can inflate the balloon itself at any rate you want, carrying the dots away from each other at a seemingly impossible velocity. This period of hyper-expansion is not just a wild guess. It's a theory that beautifully solves some of the biggest puzzles that plagued the old Big Bang model. For instance, why is the universe so remarkably flat and uniform on large scales? Inflation provides the answer. It took a tiny, potentially crumpled and curved patch of space-time and stretched it out so enormously that from our perspective, it appears perfectly flat. Just as the surface of the Earth appears flat to someone standing in a field, despite being part of a giant sphere. Inflation also explains how regions of the universe that are now too far apart to have ever been in contact could have the same temperature. Before inflation, they were close enough to mix and reach thermal equilibrium. Then, inflation ripped them apart, preserving that uniform temperature across the vast new expanse of the cosmos. At the end of this inflationary epoch, the energy of the inflation field decayed, converting its potential energy into a hot, dense soup of particles and radiation. The bang of the Big Bang. The universe was born. And here's the most beautiful part. The tiny quantum jitters, the random fluctuations present in the original quantum vacuum, were also stretched by inflation to astronomical scales. These tiny quantum scale variations in density became the macroscopic seeds for all the structure we see today. The slightly denser regions became the gravitational attractors that pulled in matter, forming the first stars, the galaxies, and the great cosmic web of galaxy clusters. Everything you see when you look up at the night sky, every star, every galaxy, is an echo of a quantum tremble in the first sliver of a second of time. The universe is not just something from nothing, it is structure from formlessness, order from randomness, a cosmos painted from the quantum jitters of the void. The illusion of the bullseye. Now, as we trace this incredible scientific origin story, we inevitably arrive at the modern fortress of sophisticated theism, the fine-tuning argument. It's an argument that seems, on the surface, to be rooted in the very science we've been discussing. It's clever, it's persuasive, and it goes something like this. As physicists have plumbed the depths of reality, they have discovered that the universe seems to be balanced on a razor's edge. The fundamental constants and quantities of nature, the strength of gravity, the mass of the electron, the value of the cosmological constant, appear to be exquisitely tuned to the precise values needed for a complex, life-permitting universe to exist. If the strong nuclear force were just a few percent weaker, atomic nuclei would not hold together, and the only element in the universe would be hydrogen. No chemistry, no complexity, no life. If it were slightly stronger, all the hydrogen would have fused into heavier elements shortly after the Big Bang, leaving no fuel for long-lasting stars like our Sun. If the force of gravity were tweaked by an unimaginably tiny fraction, the universe would have either collapsed back on itself moments after its birth, or expanded so rapidly that no stars or galaxies could ever form. The list goes on and on. The parameters of our universe, the argument concludes, fall within an infinitesimally narrow, life-permitting sliver of the total parameter space. To believe this happened by sheer chance, they say, is like believing a hurricane could sweep through a junkyard and accidentally assemble a Boeing 747. Therefore, the most logical conclusion is that there must have been a tuner. An intelligent mind who deliberately set the dials of physics to just the right numbers to allow for our existence. God, in essence, as a cosmic engineer, It's a powerful argument because it takes our sense of wonder and weaponizes it, turning our gratitude for existence into evidence for a creator. But it is, for all its scientific gloss, a profound failure of statistical reasoning built upon a single, fatal flaw: a massive selection bias. The argument completely ignores the fact that we are the ones doing the observing. This is where we must invoke the anthropic principle, which in its most basic and sensible form, the weak anthropic principle, simply states that the observed properties of the universe must be compatible with the existence of conscious observers. This sounds like a tautology, but its implications are devastating for the fine-tuning argument. It is not surprising that we find ourselves living in a universe with life-permitting constants, because we could not, by definition, find ourselves living in one that didn't. If the constants were different, we simply wouldn't be here to be surprised about it. The late, great Douglas Adams provided the most perfect analogy for this fallacy in his book, The Salmon of Doubt. He describes a sentient puddle of water that wakes up one morning and marvels at its situation. "This is an interesting world I find myself in," the puddle thinks. "An interesting hole I find myself in. Fits me rather neatly, doesn't it? In fact, it fits me staggeringly well. Must have been made to have me in it." The puddle marvels at the perfect correspondence between its own shape and the shape of the hole, concluding that the hole must have been designed with purpose, specifically for it. Of course, the puddle's logic is entirely backward. The puddle has the shape it does because it fills the hole. Its existence is contingent on the shape of the environment. We are that puddle. We marvel at how well the universe is suited for us without realizing that we are a product of that very universe. We are adapted to its laws, not the other way around. To claim that the universe is fine-tuned for us is the peak of cosmic narcissism. It's the puddle thinking the world was sculpted for its own convenience. This line of reasoning becomes even more powerful when combined with one of the most exciting, if speculative, ideas in modern physics: the multiverse. Many of our most promising fundamental theories, from cosmic inflation to string theory, don't just predict one universe. They naturally, almost inevitably, predict a vast, perhaps infinite ensemble of them. The theory of eternal inflation, for example, suggests that our Big Bang was not a one-time event. Instead, the inflationary engine that birthed our cosmos is constantly running, spawning off new bubble universes like steam from a boiling kettle. Each of these bubbles could cool and decay with a different set of physical constants, a different arrangement of physical laws. In this grander cosmic context, the fine-tuning argument utterly collapses. If you have an infinite or near-infinite number of universes, each with a random assortment of physical parameters, it's not just possible that a life-permitting one will exist. It is a statistical inevitability. The vast majority of these universes would be sterile, stillborn voids, collapsing instantly, expanding into empty gas, or having laws that forbid any kind of complex chemistry. They would be cosmic failures, dark and silent. But within that vast cosmic lottery, a few tickets are bound to be winners. We simply live in one of the universes where the numbers came up right. There is no miracle. There is no fine-tuner. There is only the statistical reality of a vast sample size. The apparent fine-tuning is an illusion of perspective, the boast of the lottery winner who ignores the trillions of losing tickets that made his own win statistically unremarkable. The answer in the question. So where does this leave us? We began our journey by deconstructing the question itself, recognizing that asking why smuggles in a comforting but baseless assumption of purpose. We've explored the cold comfort of the universe as a brute fact, and dismantled the special pleading of a necessary being. We've peered into the paradoxical nature of the quantum vacuum, the nothing that is actually a seething something, and entertained the elegant possibility of a zero-energy universe that could spring into being as the ultimate free lunch. We've traced its evolution through the hyper-expansion of inflation and seen how all cosmic structure can arise from a simple quantum jitter. And finally, we've taken the best punch theism has to offer, the fine-tuning argument, and revealed it to be little more than the triumphant logic of a sentient puddle, an illusion of perspective dissolved by the humbling scope of the anthropic principle and the multiverse. The story science tells us about our origins is not a simple one. It offers no easy comfort, no divine protagonist, no guaranteed happy ending. It does not tell us we are special. In fact, it does quite the opposite, suggesting our existence is a contingent and likely rare outcome of impersonal physical laws playing out on a scale so vast it defies human intuition. And yet, is this story not more profound? Is it not more majestic? Contrast it with the old answers. God did it. That is not an explanation. It is a declaration that no explanation is needed. It is an intellectual surrender, a conversation stopper dressed up as an ultimate truth. It takes the most profound mystery imaginable and reduces it to the arbitrary whim of an unknowable, unprovable mind. It closes the book. The scientific path, for all its uncertainty and its "we don't know yets," does the opposite. It invites us to keep reading, to keep questioning, to keep exploring. It replaces the mirage of a simple, comforting answer with the reality of a complex, awe-inspiring, and ever-unfolding quest. The beauty isn't in having the final answer handed to you. It's in the magnificent collective human struggle to figure it out. The universe doesn't need a why. The fact that it is and that it has produced minds capable of wondering about it is the most miraculous thing of all. Perhaps the answer to why does the universe exist is contained within the question itself. It exists perhaps to be questioned, and the very act of our asking is the most meaningful event within it. Thank you for joining us on this journey to the edge of time and understanding. If these ideas have sparked your curiosity, if they've challenged your thinking, then please help support our quest by liking this video, subscribing to The God Mirage, and sharing it with anyone who isn't afraid to ask the big questions. And for a final thought, I leave you with this. Having explored the origins of the universe, what do you now consider to be the most important, unanswered question that humanity should be asking? Let me know in the comments below. Until next time, keep questioning.